It's exactly the person we were waiting for. Okay, I'll start now. We're the using data to inform decision making for rural grocery stores team. That's a mouthful, but it's a better title than anything I could ever come up with. So, Harun Çelik, I'm the grad fellow, and with me here are we have Aaron, Shrika, and Alex, and we worked on the project together to build something that we think is fantastic and hopefully lives on. I'll leave the introduction of the problem statement over to Aaron and then talk about the project overview after that. So.
All right, so one of the main problems that we are tackling with this project not only affects Iowa, but the United States generally, and its lack of access to quality food. In fact, it was recorded by the Iowa Waste Reduction Center, affiliated with the University of Northern Iowa, that 111 different communities in Iowa meet the USDA criteria for being food deserts. A food desert is defined as an area with a poverty rate above 10% and not within 10 miles of a wholesome food seller, like a grocery store. It's predicted that up to 41,500 Iowans could be living in communities like these, and up to 19.5 million Americans have limited access to a supermarket or a grocery store, according to the USDA. So here you can see just how prevalent this problem is nationwide. So the research points to multiple factors underlying the prevalence of these food deserts, such as lower population growth, higher poverty levels, and lack of reliable transportation to get to these grocery stores. In addition, it's important to point out that low food access disproportionately impacts communities of racial and ethnic minorities. It's also been observed that the increased prevalence of dollar stores and convenience stores throw barriers for investment up for these grocery stores in smaller communities. A recent survey conducted by Iowa State Extension revealed the top challenges for small Iowa grocery stores were reported to be competition from larger franchises and dollar stores, as well as the availability of satisfactory labor. In this graph, we have Iowa that's just broken up into 3 different regions. Region 3 being the westernmost region, and then it goes increasingly eastward as it approaches 1. And all 3 of these regions said that their top 3 concerns had to do with competition from larger chain stores and convenience stores alike. It's also important to note that healthy food options can cost more than cheaper, more convenient options. For people in these disadvantaged high poverty communities, the cost can be too much for many families, even if healthy options are nearby. Competition from convenient food stores can have a damaging effect on grocery store profitability. And oftentimes the only kinds of stores that are capable of competing with these cheaper convenient options are larger chains, which hurts small rural community grocery stores. So Harun, if you want to describe the project.
Partnered up with FFED, and that's what I'll be calling it, the Farm Food and Enterprise Development Extension and Outreach. And we are partnering with them. We partnered with them this summer to work on addressing one solution to these food deserts. And this is with rural grocery stores, opening up grocery stores. Dwayne, a shout out needing to be mentioned over there. He provided us a tool that was originally developed in Excel. And what the tool does is it will take a number of user inputs. It will calculate a market area, so a market size, as you can see here. It will estimate a revenue. It will calculate expenses in order to give the user some informed decision-making data. And what we wanted to do was to transform this Excel tool into an environment of its own with a little bit more utility in user access. Yeah, of course. 1 second, people. Does it work? Yeah, okay. So Here we have a hex sticker, of which I'm very proud of. These are, thank you, Jay. Hex stickers are sort of it's an R thing usually, and that's what sort of brings us together. All of the functions that we've converted from the Excel tool live in their own package on a website in a repository and is online and accessible by anyone with internet access. The bigger component of that, though, is, and the reason that we chose R, one, because I love R, but two, because the R ecosystem, I think, is very good at being open source. It's very good at being inviting for any potential growth in the future and sustainability. And because our tool runs on R Shiny, another environmental tool that connects to the R environment, I think I won't talk about these so much. I just want to mention them as a sort of design choice a little bit. We needed to automate some of the processes that were inside of the Excel tool. So the user would have to input things like town populations and distances, and all of these had to be done manually. And we wanted to try and convert that to as much of an automatic process as possible. So we used a number of data sets and these things called APIs, which are just ways for us to talk to data sets that already exist on the internet. And so I won't mention Tidy Census and Tigris as Alex will, but we sort of depend on the Google API, right? It's very hard for us to just be like, okay, well, here are the nearest grocery stores, looking at a map and clicking and finding that information out. So the geocoding API helps us. When we give it an address, this is how we return a point on a map. And when we want the different places, the different stores, we use the Google Places API to do that. Anytime you use Google, you're also using these features to come up with locations and points. And I mention this because there are obviously some limitations to things like this. If you want to know more, we have a link to the data sources. My interest in promoting this blog business was that all of these are online. So if you wanted to go back in a year or two, this is how we've documented that work. I'll pass it over to Alex and we'll continue talking about each individual section of the Excel.
One of the main functions of our app is estimating market size. We can figure out how many people would potentially shop at the grocery store that we're proposing. Using geospatial and demographic data, we're able to model generally how many people would be in the store's market area. This is a picture. We're giving it an address and it's generating this circle that would show a rough market area for it. The blue regions are towns and the green circles are grocery stores. For our market area, we are finding the distance to the nearest store in each quadrant. So northeast, northwest, southeast, southwest. In order to find the distance to each store, we have to use something called the Haversine equation, which is just a model that finds distance on a sphere. Found out that drawing a straight line between points on Earth doesn't really work. We divide that distance in half to account for other stores' market areas, and then we use that as the radius to a quarter circle to figure out the market area. More elegant solutions to this would be something called a Voronoi polygon, Riley's law of retail gravitation, or Huff's model, and we'll talk about this later. For retrieving population data, we're using something called Tidy Census. Tidy Census is a package that allows you to easily retrieve and view and modify U.S. Bureau census records. U.S. Census Bureau does the decennial survey every 10 years. And that's a complete count of everybody in the country. And then there's also the American Community Survey, which is done every year and has a greater level of socioeconomic detail. But that's just a sample. So our functions use three different types of populations. They use the metro population. That's the population of the city that the store would be built in. We're finding this by parsing the address and then using Tidy Census to figure out the population of the town. We're using cities population, which is all the towns surrounding the area. That uses Tigris to find all of the cities in your market region, and then it uses Tidy Census to find the population of all of those, and it sums them. Rural population is all of the people who live in the county but don't live in any towns in that county. So your unincorporated areas. This is done by finding the population of the whole county and then subtracting the population of all the towns in that county, and then multiplying it by the percentage of the county that is covered by your market area.
So once we get the market area or the population in our market, we estimate the revenue so that we can calculate the pre-tax profit, which is the ultimate goal. So for doing that, for estimating the revenue, we need two important things. One is the average spending per capita on groceries. And then the other one is the number of shoppers. So first, for calculating the average per capita grocery spending, we are taking the total US grocery sales and dividing it by the population so that we get a baseline on how much each shopper will be spending in a store. So we took, for the functions that we used the 2022's data. So we have to account for the inflation to the present year. For doing that, we are adjusting by two different values. One is the CPI and other is the regional price parities. So CPI is the measure of change in prices. Like every month it changes. So we'll know from the time from 2022 December till now how much the prices have inflated all over US. So once we get that, we can, by adjusting to that value, we'll get the average grocery spending per capita of US of the current year. Once we get that, it's not like completely accurate because we need to know, like, not all parts of US spend the same amount, right? So some places have higher price levels, whereas others don't. So RPP is the state index, which is the regional price parities, which shows the difference in price levels for the different states. So say for California, it's going to be average shopper is going to spend a lot more on groceries than we spend in Iowa. So it's important that we account that. So RPP does that adjustment. And then this table shows the calculations for that and the yearly maintenance and update that is required for the functions that we created. And then next thing, once we get the average per capita spending, the next thing that we need is the money spent by the different categories of shoppers. So we categorize the shoppers because we don't have the same preference for a store, right? So we have different preference for different stores. So primary, we divide the shoppers into three main categories: the primary shoppers, the secondary shoppers, and the rare shoppers, where the primary shoppers are the ones who do most of their shopping in that store. And secondary shoppers are the ones who do their weekly shopping somewhere else, but they do regularly visit the store. And rare shoppers are rare visitors for the stores. So we divide those. And once we divide those, the need for dividing is a primary shopper is definitely going to spend a lot more money in that store than a rare shopper or a secondary shopper. So we are categorizing and getting the count of each number of shoppers in each category. So for that, we are using the categories of markets that we divided initially, like the metro, rural, and the towns. So metro population is obviously going to have a lot more primary shoppers because that is the town in which the store is located. So people living in that store, in that town might prefer that store more than people who are living far away. So the primary shoppers percentage is much higher for the metro population. So we get the count of the people in each categories, and then we want to know how much they spend. For that, we are adding the weight, like as primary shoppers will spend more, we're going to give like 60% they are going to spend. So we are adding weight and we are getting each category how much they're going to spend approximately in that store. Once we get that, we get the total spend for the primary, secondary, and tertiary shoppers separately. We just add them up together to get the total revenue. And once we get the total revenue, it goes into calculating the expenses, which Aaron will explain.
Sure. So the expenses in our tool are basically determined by percentages of the estimated revenue allocated to a given expense. And these percentages are based off of user input in the tool. So there'll be a slider bar that you can select your percentage of resource allocation to a certain expense. But they also are fitted with defaults. And these defaults are based off of 3-year averages from 2 financial analysis and market research firms, BizMiner and Vertical IQ. So they'll be represented as automatic tick marks on our user input sliders. And you'll see that when we open up the tool at the end of the presentation. So categories of expenses are broken up into 5 different broad categories. The first being cost of goods sold or inventory. And this is basically taking the total estimated revenue and the starting selected gross margin percentage into account, which would also be determined by a slider, and that'll determine the cost of inventory. We also have miscellaneous operating expenses, such as employee wages, officer compensation, and other operating expenses. We also cover the cost of asset depreciation annually. Some of these might include depreciation of buildings should a potential owner choose to own a building. There's also depreciation of assets like bunkers or shelves, computer systems, etc. Now we also take into account interest on any loans and also annual rent. So users will be able to enter their monthly rate of rent if they're renting a building, and that's factored into our expenses. Not only do we have expenses in the final profit calculation, but we also have secondary sources of income. One of these being income from interest-bearing assets, and other being a miscellaneous other streams of income, such as membership from discount clubs or grocery delivery service of some kind. So anything that isn't profit based off of, or revenue based off of the direct sale of goods would be considered secondary sources of income. So in our tool, the estimated expenses are subtracted from the total estimated revenue, and the secondary sources of income are then added, and this gives us our pre-tax profit estimate. And it's important to note that since the Vertical IQ and BizMiner percentages are based off of 3-year averages, they'll need to be updated annually for accuracy. So we also did a little bit of additional investigation. In our tool, we have plots with variables from the US Census Bureau. So data from the American Community Survey and the Decennial Census were pooled to display visualizations that were relevant to food desert status and the unique market features of an area. Some of these variables include median household income, which correlates with access to food, and it provides important information about an owner's potential customer base. We also have employment status, which is an indicator of poverty, and could also highlight which areas might benefit the most from the added jobs of a proposed grocery store. We also have languages spoken other than English. This gives us a sense for a unique cultural makeup of an area, and also race and Hispanic origin. So once again, this is important when it comes to food desert status and also understanding the target market. So areas with higher proportions of minority groups are most likely to be living in food deserts, as mentioned earlier, and total population itself, which is displayed in the table below in our dashboard. And this is just essential for understanding market size itself and factors into all of our calculations. So having insight into racial and cultural dynamics of a community allows potential owners to make more informed decisions about where their individual plans for stores are most likely to succeed. An example would be a Mexican immigrant entrepreneur looking to open a small market that caters to Hispanics. So here's just one example of one of these plots in this section of the dashboard. And it's worth pointing out that this is taken from the American Community Survey, and the American Community Survey is based off of representative sampling. So anything taken from the ACS are going to have these margins of error bars. In our plot, in the dashboard, you can hover over it and you can see the exact values of the estimate and the margin of error in a hover box. But for our decennial data, these are based off of exact census counts. So there's no margin of error associated with them here, or at least displayed. So it's important to take that into account when understanding the utility of certain estimates. Something might have a very large margin of error, and it might not be useful. So I guess I'll turn it over to Sarika. She has something to talk about with competition from dollar stores and larger chain stores and things of that nature.
We also did some visualizations about the rural grocery store competitions. So which will depend upon the type of stores, like dollar stores or big chain grocery stores, that will be a competition. And it also depends upon the city in which the grocery store is going to be opened. So if the city is going to be rural, or if it's going to be a city with a population of less than 2,500, or is it going to be close to a big city, is going to make a difference in the grocery store sales, right? So we used a classification which groups all the cities into 8 categories, out of which is based on population and adjacency to a big city. So out of these categories, 8 categories, we categorized everything from group 5N, which is having a population of under 2,500, as rural places. So we focused on our analysis for those places specifically. So we used the sales genius data of grocery stores and dollar stores in Iowa. So this graph here, it shows the distribution of various type of stores by the city group. So we see that this is very useful for a user. This is available in the tool as a separate tab where the user can see these visualizations from Sales Genie, which is going to be about sales volume and the store type distribution. From this graph, we can infer that as the city is getting smaller and smaller, the competition from big chain grocery stores is like significantly less. So the user can decide, like the one who wants to open the shop can decide what they can design the shop in a way that they counter the competition that's already existing. So if it comes to smaller cities, it's going to mainly be just the other non-chain grocery stores in that city than from any big chain stores or dollar stores. So this can be found in the tool. And then Alex also explored some alternative ways to calculate the market areas. So he'll be explaining about that.
Yeah, during our research process, we found several different ways that you could find other market areas. We found both geometric approaches and economic approaches. A more accurate implementation of the quarter circle method would be something called a Voronoi polygon. And then there's also Huff's model and Riley's law of retail gravitation, which are designed by economists to give a more accurate estimation of market size. These are Voronoi polygons. Voronoi polygons are a way of partitioning a plane into cells where all points within those cells are closer to a given store than any other store. In this picture, they're color-coded, so you can see like this purple one. Anything that's purple would be closer to this store here. This would scale up to more stores than just 4, like in our current model. There's also something called Riley's law of retail gravitation. Riley's law is the idea that people are more drawn to shop in areas of higher population than lower population. An issue with this is that these maps are normally edited by hand to account for geographic barriers such as rivers, hills. And also, they have to be relatively similar sized cities for this model to work. Another model is something called Huff's model. Huff's law is a probabilistic model for estimating consumer attraction. It states that people are drawn to stores based on their attractiveness, but they're also discouraged from going to stores that are further away because of something called distance decay. Distance decay is the idea that as you move further away, people are exponentially less likely to go to your store. An example of this would be if a store is 10 times more attractive, but also 10 times further away, you're most likely not going to go to that store. And then Haroon is going to finish us off and give a demonstration.
Okay. Huff's Law is the reason that I don't go to IKEA in Minnesota. So I want to share just a couple of seconds so that I can share my screen to show some of our final results. I'll briefly mention them and then talk about them a little bit. I'm very proud of the work we did. I think we did a lot, and hopefully the dashboard will demonstrate that. But for our deliverables, the first major thing is obviously the app, the tool itself. I think that has longevity as long as it's continued, as long as some of these considerations are being followed and have the potential to be followed. We also have the package page, which I'll show in just a second. It's well documented. I'm known for nagging about documentation. So we hope that, that documentation also helps to improve a lot of the utility in there. We have the reference page. We have the repository and the reference page for the package. And we have the blogs of each individual member and our team blog that chronicles all the progress we made. So if a team wanted to pick this up in the future, they look at the blog and they say, well, we have this crazy idea of using Euclidean distances to find stores. We tried it. And so if they read our blog, they would understand that this is maybe not the way to go and the reasoning for why that is. So in just one moment, I don't want to expose our secrets, sorry. I think Adasak will be very mad at me if I show the key. Okay. And then stop here. There's a lot of tech. Okay. People are seeing this DSPGGrocery screen thing now? Yes, awesome. Okay, so the first thing I'll show is our package website. This is the web page that's generated from our repository. What that means is online, we've saved all of our work and progress online. You could literally go back to the first thing we ever pushed as work for this. So if you're really interested, you can read almost all of 600 commits. But this page is a little more user-friendly. So this is where we would find sort of the main information and some of the technical details about what's happening inside of our package. In the article section, all of the students mentioned about their individual sections. We have a little bit more that's going into here. But if you were interested in learning about the expense estimations, you would go into that particular vignette. And here, Erin has done a fantastic job of describing what's going on. Additionally, if you were like, oh, well, I'm a little bit more interested in what's actually being factored into the calculations and how that's happening, you can click each of these functions that are being referenced, and because they are linked to our package, they will automatically show up. So here you can see that in our depreciation one function, we use to calculate a depreciation for a particular scenario. These are the variables that are going into it. And you could look into the different values and arguments and see what's happening there, right? So I think this is a great way of also giving authorship and credit to the students for the hard work that they've done. And it really helps, I think, keep it moving forward. Here's an example, for instance, with these default values, you would get a depreciation of something like this. Oh no, the secrets. So here's what our tool looks like. I'll run it. I'm a little scared. It's a live demo. So our tool opens up, and this is what the launching page looks like. The landing page. The landing page has the steps that are necessary for running through the tool. Each of the steps highlights more or less the calculations that went into the Excel tool. There are variances just because we were able to do some of the things simultaneously and/or our calculations did not work exactly in the same way as the Excels, and that's all documented here. And I've also added potential errors. So if you do use this and right now, because the application is sort of infantile, it's a 10-week program. So if you run into errors, here are some potential reasons why. Here are some ways you could not run into those errors or try and find alternatives to solutions. So the first steps are really about outlining how to use the map. The biggest thing here for now is the calculations that are in the Excel tool are not currently the same ones that measure the sort of market area. It's not a perfect circle in the Excel sheet that Dwayne created, but we are using that a little bit for simplicity and a little bit because it was harder to create those different geometric shapes to match with our data sets. So there is an overestimation there, potential overestimation, most likely an overestimation. The formats and the inputs are all described here. I won't bore you. In the second step for profit estimation, we have a list of all of the different inputs that are going to be listed in just a minute. So if you're not sure about what any of these particular inputs mean, you could look over into this area for a reference section and how each of those sort of values that you'll see in the value boxes are calculated so that you're not left in the dark about what's going on behind the scenes in the calculations. These obviously have room for improvement. If some things aren't there for clarity, this can be quite easily fixed, but it's for documentation purposes. And finally, we have an overview of the plots. So these three sections here generate plots based on our map area. And so these are descriptions of what those plots are. Aaron touched on those and Trika also for the rural grocery store analysis, but a new user would find that information here. So let's go ahead and try something. In this section, in the store maps section, the user, I'm sorry, I have this very weird, okay. In this section, we first try to identify where we would like to open up the potential store. And for this, we give it an address. The address is given in the format of street, city, and state abbreviation. And those are the values that we take and call a bunch of other online resources that will try and give us different shapes and geographical areas to calculate those things. So here we have an example that we know works. I'll run the calculation. So we have a progress bar that kind of keeps you in the loop about what's going on. It could take up to 20 or 30 seconds, and depending on internet speed, maybe more, maybe less. But it's pulling in the store location. It's geocoding that. It's finding all the nearby stores. It's saying, okay, to all the nearby stores, let's look at only the grocery stores. And when we're looking at only the grocery stores, let's look at only the 4 grocery stores in different quadrants. And then let's make a buffer half the distance to the furthest grocery store in a quadrant. There's a lot going on, but once that's done, we can map the retrieved data. And if the pull was successful and your app doesn't crash, this map data section on the right side will display a little bit of information about the market size that's being calculated. So in a minute, because we gave it Lamoni, Iowa, it will create that buffer, and any intersecting cities we're done. So any intersecting cities will come up here. So we see that in this market area we calculated, we have Kellerton, Davis City, and Lamoni, and these are the counties which also intersect in the same areas. The counties are being used to generate the plots in Aaron's section, which we'll come to. Let's collapse that. So here is showing you all of the counties. This is an area that intersects 2 states. This was very difficult to implement. But you'll see that, we have a city. This is Lamoni. I think it's Lamoni. We don't know how it's pronounced. And this is Kellerton up in the top left circle. So that information will be included. We have Davis City, and that information will be included. And as Alex mentioned, each of these points represents some kind of store that the API was able to pull. So you can see here, non-grocery stores will not be factored into the market area size calculation, but they will be displayed because dollar stores are not considered grocery stores, even though they're a major competitor. So in this example, we have a Family Dollar here, right? But that doesn't get considered into the calculation of the circle. What does it, though, is stuff like this, where we have a Hy-Vee grocery store. And I think in this example, that's the furthest store in our area, right? So this is the circle. This generates some sort of total estimation value. So when we move on to our next tab, we have these value boxes here, which demonstrate just sort of with default values. None of us here are specialists in this area. We don't know what numbers to put in here. So we took some of the values that Dwayne had and then maybe made up our own, sorry, Dwayne, to demonstrate. So what happens here is you have two different scenarios, which are documented. In scenario one, you are owning the building, and so there are different costs associated with that. If we click onto the second scenario where you lease the building, some of those things change. We now have a monthly rent we need to pay, unfortunately. There are some leasehold improvements and the use life years, things like that. So in the own building scenario, if I was very, very much interested in upping my revenue, I mean, I would maybe choose an aggressive gross margin percentage, and that gross margin percentage would affect the pre-tax profit. So you can see that these updated sliders make a change. Let's do some crazy stuff here. Yeah, so obviously we're gonna have no profit if our shelving costs are that high. But the idea is that all of this will display information dynamically so that you could look at adjusting values which more accurately represent the information. The total revenue is calculated by market size. So in most of the cases, we do end up with some kind of total pre-tax profit. This tool is not financial advice, legal financial advice. We don't want this tool to make people think that, just because they open it, just because the tool gave these values, they'll automatically make profit. There's more to it than that, but I hope they know that. Moving on. These are the plots that are generated by the market area. If a market area is successfully generated, we get these kinds of plots, and Aaron showed some of those. Here's one about median household income. If you hover over them, you'll see the estimates for each of the counties, as well as the margins of error for you to decide whether to use the values or not to use the values. These are made in Plotly, so they are interactive. So if you just wanted to see one or not the other, you could do something like that. You can compare data sets with different kinds of clicks and save them as PNGs and things. And similarly for an employment plot here. For the census demographics, a similar thing is being generated. We generate the languages, the top 3 languages that are spoken in that particular county. These are going to have larger margins of errors for rural areas. So it's, obviously something to factor in, but, here in Ringgold County, the top 3 would be Tagalog, Spanish, and German, other West Germanic languages. Whereas in the indicator county, you're looking at other Indo-European languages instead of the Tagalog, right? So that might factor in. And we have a table of the race and ethnicity makeup of those counties taken from the decennial census. Finally, we also have this section where Shrika's created these graphs to show distribution of grocery stores by type and non-chain grocery stores for different sales volumes, and so they're similarly interactive. But what we were hoping for in this section, the tool is as a national tool, it works beyond just Iowa. So as long as the address is geocoded properly and our things match, it should be fine. What we wanted here, though, is if there was additional information about different regions of the US that had surveys and information on what different store makeups existed, this could also help inform that decision-making a little bit more, right? So the closer we get to a more accurate representation of our area, I think the better the tool is adjusted for. There are caveats to the tool and obviously things to improve on, and we're finished up some of the documentation for that. But as it currently stands, this is what our tool can do. We are very open to any questions you may have now. Thank you.
Great, Bob. So you're in a really good position right now, given whatever data struggles you might have had. If you could advise ISU Extension or SBDCs, if they were going to try and do a survey of either grocery store owners or grocery store shoppers, what types of information would you prioritize that would have improved your model, in terms of shopping habits or patterns or things like that?
I think I'll try and answer it if you guys want, you can, yeah. I think the biggest thing is actually the market area calculation. So whatever survey would help create better estimates for a market area, market size, would probably serve the tool the best, because a lot of the calculations are based off of the total revenue of the market size. And so if we had more reliable information about how market sizes work for their particular cases or for larger regional cases, I think that might help create better accuracy for the tool. Does that answer?
I would also be interested if you asked grocery store shoppers how far they would be willing to travel for groceries. And then if you had any data from owners of like where their shoppers are coming from, that would be interesting too.
Yeah, if we're getting into surveying shoppers, maybe talk a little bit about the online aspects of like online grocery delivery, which is, threatens to take up a lot of the market in for rural grocery stores, like Amazon delivery and GoPuff and things like that. Like, how much growth is there, and how much is that taking away from the market of these stores? Things of that nature.
So I was wondering if you could just go back to I think it's your profit estimation on your tool.
Uh-huh.
And can you just scroll down the expense estimations that oh, okay. I was just looking to see what you included or not. Okay.
So in both of the scenarios, there are miscellaneous assets. In the Excel tool, there were 3. So we, for now, just kept them at 3. But the idea is that these values would be taken along with their use life and then factored into the calculation. If I did, I'm just going to put in crazy numbers because it makes the biggest difference, I guess. Yeah, right. So it's like it changes the depreciation costs and things like that, right? I think, yeah.
So great job. This is awesome how much you got done in this short time period. Way to go. Great work. So one thing I was curious about, at the very beginning you were talking about, and I don't know this field, but you were talking about figuring out the average amount, the spending of each person based on the kind of full pie. And I wondered if you thought about weighting that based on, socioeconomic factors or anything rather than just giving everyone an equal weight by population.
So this section, correct? With the rare primary shoppers, this. Yes. Have you thought about that, Shrika? We're thinking about it. We'll continue thinking about it. Thank you. I'm sorry, Shrika. Go ahead.
I think it's more treated like equally only because it just depends upon, it's just weighed upon only weight that we giving us like the price levels according to the state. Other than that, I don't think we have implemented anything, but we could.
Super interesting. And I was also thinking like you could do you have all the data on the employment and the average income in those areas. And you have it nationally. So you could calculate nationally the likely, what everyone's income is, because the money that they're spending is probably based more on their income up to a certain level. Like I bet it, there's a ceiling on that, but there is an amount where it would be really interesting to see, because if you're in a very poor community, for example, that might not impact the spending as much as in a different kind of community. So I'd be curious how the generated income and wealth would impact that.
If you did your shopper survey and you had a variety of diversity in your respondents, of those shoppers. You could ask them questions about what they were buying and where they were going and so on, and be able to tease out, you know, how these racial minority differences impacted that, or by family size, family type, female householders with children, single females with children, and so on, that kind of thing. You could tease some of that out with a shopper survey if you did the shopper survey. So there you go.
I think too, you said, how do you add to it to make it be more reflective of what's going on? I think it would be interesting to see this with to catch growth or depletion of communities. Communities are shrinking or communities are growing, whether it be through like building starts that might pick up communities that are going to be growing that maybe don't show up as underserved today, but they're heading that way. Affluent suburb building and so forth. And then it could go the other way, of course, areas that are shrinking in population that may end up seeing stores closed because they're getting smaller. So that'd be an interesting way to look at this too.
I think we could touch on that potentially in a future improvement by introducing maybe time series trends to our dashboard, seeing like areas of high population growth or even low population growth, because we discussed in the introduction that areas with the low population growth are most likely to be food deserts. It's one of the primary indicators. So yeah, I think growth is important, being able to get some kind of indicator for that.
Yeah, hi. Hey, first I want to thank the team for doing such a nice job with this. They took what were some pretty basic ideas of mine and went a long ways with it. So I really appreciate that. My question is about going back to the primary, secondary shoppers and all that sort of thing, which is kind of more global look at what everybody's talking about here, but in terms of defining how many people are going to shop at the store and how many are still going to go to Walmart. Did we make those so that they can be tweaked, or are those fixed numbers for the primary, secondary, and so on?
They are in the functions themselves. They have default values, but if we wanted to, we could change it so that it takes like for that. I think, I mean, the biggest thing is with any improvements of these, like we need to redesign the process of how the application works, because we have to follow a series of sequences for pulling all the data first before we display. But if we did want to make, for example, city changes, we need to pull the ACS before whatever. And so I think future implementations are very much possible given certain design priorities.
I want to echo Cass and say phenomenal work for 8 weeks. It's just very impressive, the quality and volume work. We have a hypothetical.
And actually, it was only 6 weeks because I didn't have to start working on the project.
Wow. Now you're just showing off. Hey, it's next year, and you have a new client comes on and says, "We saw this grocery store project. It's awesome. We'd like to do something like that, but we're interested in clinics or treatment centers." Or we're looking to identify places to put parks and green spaces and recreational amenities. How much of this tool is usable? Could you, as a starting place, 10%, 80%? How localized is it to the grocery store context?
So the calculations are purely for the grocery side. But I think the Google API calls would be relevant pieces if we're looking at different clinic centers. So if we had data sets which pointed those out already, or we generated them from some kind of poll, I think it would be quite possible. We just need, I think, more information than what's provided by the APIs. So one of the big limitations we faced is the API calls are not always consistent. We were originally using a Google call to return an address for a place. But if a place is administered not as a city, but as a village, the list is different. And so like our matching for those different areas has to change a little bit. And so my question kind of back would be, how much information are we having at hand for those places? And if the information is available, then I think it is possible to do. Yeah.
Yeah. Other questions? I think it's pretty good work for, let's see, a data scientist, a linguist, led by geography. Wasn't their space either. So they had to figure this all out and dig deep. And I know there's a lot of extra hours put in to get this to work out. So good job. I really am glad though you did drop the extra G in your Hex logo, which they will make available eventually if we want Hex logo stickers for your computers. Everyone's going to be working on getting those for us.
We object to that, but it's totally fine.
G.
We want the double G.
They did tell me though that as long as I go to the GitHub site and I edit something with even just a space, I get credit. So thanks.